Yeah, sorry.
It had to happen.
Yeah,
I would have felt robbed if someone had not been on mute.
Yeah, sorry. Can you see the slide?
Yes, we can.
Yeah, just my Zoom window crashed for a moment. Okay, so hello, I'm Wan-Ying Chang, and I work at the National Center for Science and Engineering Statistics, a federal statistical agency, sits within the National Science Foundation. And I want to draw your attention to a set of new research data on the US trained PhDs. And it is created by NCSS projects with collaborators from the Coleridge Initiative, IRIS, and the Clarivate. And in this presentation, you will see surveys, administrative data, transaction data, and bibliometric data all come together to offer new insights. So NCSS is the nation's leading providers of statistical data on science and engineering enterprise. And we specialize in R&D and SNE education and workforce statistics. We also produce 2 congressionally mandated reports, the Science and Engineering Indicator Reports and the Women's and Minorities and Persons with Disabilities in Science and Engineering. And both comprise a broad range of high quality data that goes far beyond our surveys to give a complete picture of the US and international science and engineering enterprise. And we conduct more than a dozen surveys. And the network of data I want to highlight today is centered around 2 surveys, the survey of earned doctorates, SED, and the survey of doctorate recipients. So if we look at the timeline, SED occurs at the time when one completes the doctorate. SED is a census survey given to all research PhDs in all fields, including humanities. And about 2 years later, SDR follows up a random sample. About 10% of new grads earned a PhD in science, engineering, or health field. The SDR follows a longitudinal design and continue to contact sample members every 2 years until they turn 76. SCD and SDR have been a unique source since the 70s for research on this population. And a large research agenda is formed over time, and some concerning graduate training, such as how does funding of students differ by field of study, by race, ethnicity, and by gender, and some concerning employment outcomes, productivities, and with topics ranging from scientific publishing, patenting, labor force mobility, state rate of foreign nationals, international collaboration, to the effect of diversity on research network. NCSS data linkage efforts are motivated by the fact that survey data alone cannot address all these questions and fill all the data gaps. So here is the data schema with some examples of data items. SED and SDR are connected by survey design. SED collects educational history data starting at the bachelor's degree in details of the doctorate, post-graduation plan, and background demographics. And with SDR fills in employment information every 2 years. The U-Metrics employee file built from transaction data are linked to SED for those classified as graduate students and completed a doctorate. And with this link, connection to other parts of U-Metrics, such as the award file built from administrative data, become available. And direct linkage from SDR to U-Metrics is underway to add data on faculties in U-Metrics institutions. About 1.2 million publications indexed by Web of Science are now linked to 2015 SDR respondents. And the bibliometric data such as author affiliations and citations add great value to this design. And later this year, we'll begin linking SED-SDR to inventors in patents field. So next 2 slides, I will give you some early findings from this data network. The SEDU metrics linked data give new insights into funding level and source for doctoral graduates. And we see match rate varies widely from 12% for social science PhDs to 48% of the physical science PhD. In field of study is the dominating factor of other observed differences by gender and race. For instance, the match rate for African American PhDs is 18%. And that goes with the fact that 51% of them earned PhDs in social science and non-SEH field. So for the matched PhD, we can classify them as receiving only federal, only non-federal, or both federal and non-federal support. So this lower chart reveals that some fields like social science are less reliant on external funding to support doctoral training. And we can also use U-metrics data to compute the funding duration. And when combined with the primary source of support reported in SED, get us closer to understanding the association between the research experience and the type of support.
Wan-Ying, you've got 1 more minute.
Great. So we can see the third chart shows that those supported by research assistantship have higher proportion with longer duration of support. The linked SGR Web of Science data make it possible to study scientific publishing at different career stage. And we first calculated the pre-PhD publishing rate as the proportion of those who publish at least one article during the 5 years before earning PhD. And this heat map shows that pre-PhD publishing rate by field of study and by source of support. And we can see the rate varies by both factors. And those supported by fellowship grant and research assistantship generally have higher rates. And for a selected cohort where we have the complete data to study the pre and post PhD publication output, we compared the publishing patterns to job outcome from the survey. So this alluvial diagram summarizes the indicator of publishing for 3 periods: pre-PhD, first 5 years, post-PhD, and 6 to 10 years, in relation to the type of job they held in 2015, whether it is the academic position with R&D focus, R&D position outside academia, or other types. And we can see that those with pre-PhD publications are showing persistent publishing pattern post-PhD and have a higher rate to land the academic R&D job in 2015. So I hope these examples get you excited about the new data. So please visit our website and get in touch with me for any question about the data. Thank you.